This video deals with defining piecewise functions. So the piecewise functions are going to be given to us already graphed, and then we're going to have to take each piece of the graph and create a function rule to define it. Each function rule will be accompanied with a domain restriction that we also have to define. Our first example, we have three pieces of this function here. We're going to start from left to right, and we're going to notice that the first function to the left is a horizontal line. So whenever we do our piecewise function is going to be y equals with some curly brackets. Horizontal equations or horizontal lines have an equation that looks like y equals a constant number, whatever number the y value is on the axis, the y-axis. So in this case, that line is y equals 0. So our first piece is going to be y equals 0 if x is between. The arrow indicates it goes from negative infinity all the way up to this open point, which is negative 4. And because it's an open point, we put parentheses. The next thing that I suggest is that you look at the next function, and if you have a difficult time drawing or defining this type of function, you need to first recognize that it's linear, and then we can use our graphing calculator to put a table of points and then get a linear regression. So our x and y points for this middle function here is negative 4, negative 4. That's the first point right here. And then 0, 0. Well, we can then put that into the calculator and come up with y equals mx plus b as a linear regression, and that's what we're about to do. So when you're in your calculator, you want to go to a list and spreadsheet, and you want to put negative 4, 0, 0. And then hit Menu, Statistics, Stat Calculations, and then Linear Regression. You need to put your X list is column A, your Y list is column B, and hit OK. And here you'll see that X has a coefficient of 1 and B is equal to 0. So our equation that we just generated was y equals 1x plus 0. Now I don't need this 1 in front of the x, and I don't need plus 0. So our equation is actually y equals x if x is between the two numbers. It's between negative 4 on the x-axis, and that requires a bracket because it's a solid point. You'll see that it's a solid point if you go back to it. And then x goes to 0. Again, 0 is a bracketed value because there's a solid closed point. The last piece of this function is the one that looks curved. We need to get, if it's curved, we need to get at least 3 points that we can put into our calculator. And we'll see those 3 points. We'll make our table. And it looks like we have a point 1, 3, 2, 0, and 3, negative 5. Well, the purpose for looking at the parent functions at the beginning of class was to notice that this is a quadratic equation that's just upside down. So I'm going to put these points in my calculator and do a quadratic regression. So when I do a quadratic regression, I need to go back into my list, create a new list, and my points are on the X list 1, 2, and 3. On the Y list, they are 3, 0, and negative 5. I'm going to hit Menu, Statistics, stat calculations, and you'll see option 6 is a quadratic regression. Again, we want A to be the X list, B to be the Y list, and we have our quadratic regression. You'll see that this right here for B is an extremely small number. Anytime you see something like that, it's going to equal 0. You should also here see that A is equal to -1 and C is equal to 4. So our equation is going to be -1x squared plus 0x plus 4. Now we don't need the 0x or this 1, so our equation is going to be -x squared plus 4. So we'll write that again, y equals -x squared plus 4. Now that's going to go into our function rule. And now we need our domain restriction. If x is from, it looks like an x value of 0, but because there's an open point, there's a parentheses, and then this arrow right here indicates it goes to positive infinity. And there is our function rule for the graph provided here in example number 1. Our second example is going to be significantly easier. There's only 2 pieces, and it looks like they're both linear equations. So all we need to do here is get 2 points from each of these lines and use the linear regression tool on our calculator to come up with the 2 equations. So our first equation, we're going to get the 2 points. Looks like 0, -1, and then 2, -5. Our second graph is going to get the points, looks like 3, 1, and 5, -1. So we're going to find the y equals mx plus b equation for both of these by using our calculator. So on your calculator, make sure you open up a new list. And our points were 0, 1, or 0, -1, 2, -5. So 0, -1, 2, -5. We go to menu, linear regression, A, B, and our linear regression here shows -2 for M and -1 for B. So this equation is y equals -2x minus 1. And then if we go back to our calculator, do a new spreadsheet, our points that we see here are 3, 1, and 5, -1. Go to our menu, and then do another linear regression. And we see that M is -1 and B is 4. So the second equation is y equals -x plus 4. And so there's our 2 function rules. So we have -x plus 4 is the second equation. We have 2x, -2x minus 1 is our second equation, or is the first one really. So this first equation's domain restriction is if x is between, we see that this arrow points in the direction towards the left, so that's negative infinity, all the way to x equals 2. And if we recall, this is a solid dot, which requires a bracket. The second one, this goes all the way to positive infinity, which means infinity will be over here. And then the x value here is 2, but it's not a closed circle, so there's a parentheses. So these are the two functions or function rule for this graph, and this is the second problem of the two that we were going to do. Guys, this is defining piecewise functions with a graph already given to you.